Today, I will be discussing about the link reaction before the Krebs cycle. Link reaction. The pyruvate made by the molecules by glycolysis will now continue to oxidize and break down so that we can release all of the energy that was available in our glucose molecule. The rest of this breakdown will happen inside the mitochondria, so pyruvate moves into it. Once inside, pyruvate oxidizes, transferring electrons and hydrogens to NAD+ to form our favorite electron carrier, NADH. This also breaks down the pyruvate, causing the release of carbon dioxide. You may recall that carbon dioxide is one of the overall products of cellular respiration, and that we ultimately release 6 carbon dioxide molecules for every glucose that enters respiration. Well, here we see 2 of those 6 carbon dioxide get released, and ultimately you breathe them out. The NADH will be used in the electron-2 transport chain, from which most of our ATP comes, and the acetyl-CoA will be fed into our Krebs cycle. Out next stage. This is why the reaction we must show is called the link reaction. It links or connects glycolysis to the Krebs cycle, allowing respiration to continue. Now, let's tackle about the Krebs cycle. The first step involves actually a preparatory step which begins with the pyruvate. Pyruvate is derived through the glycolysis of glucose, which is a 6-carbon compound, and it is split into 2 molecules of pyruvate, which is a 3-carbon compound. The next step includes the oxidation of pyruvate into acetyl-CoA by the enzyme pyruvate dehydrogenase complex, and in this reaction, a molecule of carbon dioxide and a molecule of NADH is generated. The acetyl-CoA is a 2-carbon compound. The next step is the acetyl-CoA combines with the oxaloacetate, which is a 4-carbon compound, to form citrate, and hence the resulting molecule is a 6-carbon compound. This reaction is catalyzed by the enzyme citrate synthase. In the next step, the citrate is isomerized into isocitrate by the enzyme aconitase. Next, the isocitrate alpha-ketoglutarate by the enzyme isocitrate dehydrogenase, and in this reaction, a molecule of NAD is reduced to NADH and a molecule of carbon dioxide is generated. Hence, alpha-ketoglutarate is the 5-carbon compound, since 1 molecule of carbon is lost into carbon dioxide. The alpha-ketoglutarate is converted into succinyl-CoA by the enzyme alpha-ketoglutarate dehydrogenase, and in this reaction also a molecule of NAD is reduced into NADH and a molecule of carbon dioxide is released. Hence, the succinyl-CoA is a 4-carbon compound. The next step, the succinyl-CoA is converted into a succinate by the enzyme succinyl-CoA synthase. In this reaction, a molecule of GTP is generated. Next, succinate is converted into fumarate by the enzyme succinate dehydrogenase. In this reaction, a molecule of QH2 is generated, which is used for the production of FADH2. Fumarate is then converted to malate by the enzyme fumarase. And in the last step, the malate is converted into oxaloacetate by the enzyme malate dehydrogenase, and in this reaction also NAD is reduced into NADH. Now, this is the result of a Krebs cycle. Through each cycle of the Krebs cycle, the following products are generated: 3 NADH, 1 FADH2, 1 GTP, 2 carbon dioxide. So since glucose is split into 2 pyruvate compound, for a molecule of glucose the cycle runs twice, hence the product forms are 6 NADH, 2 FADH2, 2 GTP, 4 carbon dioxide. All of NADH and FADH is used the ATC for the generation of ATP.